Namaskaram everyone, welcome back to the 51st episode of our Master Unreal series, and in this episode we are going to finally start the stage 3 which you have been requesting on Discord from past couple of days. And if you haven't watched the last two episodes, I highly recommend you do that because we have already set up the travel behaviors components and objects and everything. So in this video we are going to first cover the behavior trees findings and the limitations, and then we will see how the state tree overcomes, and then we will take a look at the interface. We'll try to do the reverse engineering. What are the things that have been developed? What are the new features that state tree brought, like data binding, transitions, states, linking the states, parameters, global tasks, evaluators. So we are going to cover all those things in detail, and I'll also give you some of my own tips which you can use to create scalable solutions. So without wasting any time, let's get started. All right, so we are going to consider the Escort Travel behavior that we implemented in behavior tree, and also people who are not checking out the last two episodes, out of curiosity, let me summarize this for you. This behavior tree that we are taking belongs to the Escort Travel behavior. So the idea is there is a AI and it has a set of companions which can include player, and the AI is going to escort you out from one location to another destination. Okay, so let's have a look. There is a service that is constantly running and keeping track whether there is any companion that is left behind. Okay, are all the companions within range, and if there is a companion that is left behind, then it will update its position, which can be used further, and some boolean variables that we have listed here. Okay, so we have whether a companion is left behind or not, and if it is left behind, then whether he came back within the acceptable range or not, because that's what will decide whether we should resume the escort or not. And then there is a escort destination where the escort is going. Then we have some data about the escort, and then we have the information of the companion that was separated, and we have the successful acceptable radius, which means the escort will be considered as successful if the leader gets within this range of the target destination. Okay, so these are some information which this service is constantly evaluating or updating, right? And based on that, we are making some decisions in the behavior tree. Great. So once the service is initiated, you will check whether there is a companion left behind. So if everyone is together, then we would like to clear the focus and we will move towards the escort destination. And once we reach to the destination, we will notify the external entity, for example, a mission manager, that my escort is over, which means the AI has reached to the destination. Now remember, you will not be able to execute this task if this move to doesn't complete successfully. So let's have a look at the other situation. If there is a companion, let's say for example the player, you by yourself run out of the group, that will pause the escort. So the service will pause the escort and then it will keep track of you, and based on that distance it will work out its further decisions. So let's say you went out of the group circle, then the leader who is leading the escort will focus on you and it will perform an animation, or you can go for a dialogue as well, and it will wait for 2 seconds and then it will wait for you to come back. And if you don't come back, then it will again do the same thing, it will call you. But if you come under the acceptable range, then it would wait for you to come within a resumable range, and once you do that, the escort will begin again. Okay, that's the higher level overview of this entire escort situation. Great. Now let's conclude our findings so that we can transition from behavior tree to state tree. Have a look here. There is something very important in our entire graph, that are these blackboard conditions, because these are the things that will decide which flow to execute in the behavior tree. Then there is something called as task, which actually represents the behavior or the implementation of the AI. Great. So let's focus on the task, which is always our first objective. First is you clear the focus. I know both of them are looking same, but actually the separated companion will be null. So it will clear the focus because this is not valid. Okay. So first step is to clear the focus so that you can focus on the escort destination. Second task is start moving towards the escort destination. Third is focus on the companion. Fourth is call the companion. And fifth is wait. The escort over is also a task, but right now I'm keeping it separate. So for now, let's say there are 5 major tasks that are happening. Let's have a look at the conditions. You want to know if the escort data is fetched, because if the escort data is not fetched, you will not know what is the target destination, who are the companions, who is the leader that is leading the escort. So all that data is required. Second is, who's the companion that has been separated? Or let's just say, is there any companion that is separated? Because this condition will decide whether you should stop the escort or resume the escort. Third is, once the escort resumes, it will continue. But if the escort stops, then it would like to keep track of the companion that went out of the range so that it can begin the escort again. So there are 3 major conditions in our entire escort travel behavior. Okay. So now let's summarize these findings into the left side. Okay. These are the conditions and these are the tasks that we did in the behavior tree. Now the state tree is in the picture. So we will use the reverse engineering art to understand the pattern, the implementation, and the features of the state tree. To reverse engineering, first we need to know what is the final result or the product that we have. So we have this state tree, which is made up of bunch of states. And now the first question arises, how we make the states, because we just know what are the activities or tasks involved in our entire process. So we have our list of tasks here. Now I want you to read one by one with me and think whether it is a state or it's an activity. Clear focus. It's an activity that you are doing in a state. Okay. Second, move to target destination. It is an activity of a state. So I can make this a generic state that is move to the target destination. And in this, first, I would like to clear the focus. That is the first activity. Second, I would like to use the AI move to that is being provided by Unreal Engine to do the movement, which actually represents the activity again. And the set of activities is called state, and I want to name that state to move towards the target destination. Second, focus on companion. Again, it's a part of the activities set. Call companion. This is also part of the set, and together we can make this call companion state, which will be activated or will be initiated when the companion goes out of the range. Okay, so state is nothing but a set of activities, or even a single activity can also be called as state. For example, the wait. Wait means doing nothing, and doing nothing is also a behavior. It's a activity. Now, with the help of these states, we will understand the interface of the entire state tree. So let's have a look. I will put these states in the left side, and again, just like behavior tree, we have a root. That means the starting point of the execution. Now have a look here. I will increase the application scale so that you can see it clearly. Now, I don't want you to by heart this. Just focus on your objective. What is it that you want to do? Your goal is to create these 3 states in which you can define the behavior. First, you define the state in which your character can be in, and then you define what are the behaviors or instructions that your AI is going to execute when it is in that state. Okay, these are the only 2 things you have to do. Don't think about any conditions, what is going outside, nothing. Your primary objective is to define the state and the set of behaviors that you want to get executed under those states. Now, first, let's have a look on the interface. So first thing is your schema, in which you tell about your character or actor that is going to use this state tree, which is nothing but a pattern or a lifestyle of that actor you have defined. So there is a controller and then there is an actor. These are the 2 primary things which the state tree needs to know. Second comes up the context. So the execution of this entire interface goes like this. First, it starts from the leftmost panel from top to down. Then it goes to the second, top to down. And based on what is selected here, it will show you the details. And again, it will go from top to down. So the flow is always top to down. Okay. Then the second thing is a context. In the context, you can define the variables that are going to be essential part of your entire state tree. So like I said, you need to know the controller that is being possessed by the actor for whom you are creating this tree. So we provided those values or references from the memory. If you haven't seen the video where I've explained how the memory management works and how the programming actually executes in the RAM and in the processor, then I will highly recommend you check that out, because it is going to help you a lot in terms of understanding how the data flows when you are programming. So we have the reference of the actor and the controller. Then there is a section called parameters. Now parameters are the variables or the values that you want everyone to use, be it your evaluator, be it your global task, be it your states. Every state has a certain characteristic. Everyone can access this parameters data. So if you want to share a data globally, then you can declare them in the parameters. Okay. Second is your evaluators. So evaluators are something that continuously run till your state tree does not complete. Okay, when I say complete, either the tree successfully finish or the tree successfully fails. In our case, the escort is successfully completed or not represents the outcome whether the state tree is successful or not. So till the state tree is running, the evaluators will run. And evaluators, the primary job that you should do in evaluators is just to construct the conditions. Mark my words, construct the conditions based on the data that you have gathered from the context and parameters. Period. Is it just about conditions? No, you can also create data and outsource it to everyone. And the entities that can use that data are the global task, the state tree, and whatever that is there inside. So the bottom line is evaluators should be using the data that is above it, which is the context and the parameters, and you are going to construct the conditions which are going to help the state tree to make correct transitions. And if you want to generate some data in runtime, for example, making a line trace and detecting what are the interactables nearby, you can do that in the evaluator. But if you look at it carefully, you are generating a line trace from the actor. So idea is you should always rely on the context and parameters. If you stick to this line, you will use evaluators wonderfully. We will go how to use it, but let's focus on the sections first. Then we are left with the global task. Global tasks are something that starts before the state tree comes into the execution. And it's your call whether you want to keep them running or you want to end them after you accomplish your objective. So the idea of global task is to fetch the data or get the data from anywhere that is required by the state tree or the tasks of the state tree. Okay. In global task, you can do everything. There is no barrier. You can access anything that is above or associated with these in the real world. Okay. So the global task will run before this state tree starts executing. Okay, so I hope I summarized it pretty well for you. Now let's focus on the state tree. Every state tree will have a set of states which are connected based on your decisions, and we will go into it. But first, let's see what are the properties that a state carries. So if I focus on this root state, there is a section of having a name and a tag to identify the state. If you want to connect with the state tree from the external entities, then there is a type. You can define a state. You can define a group, which is nothing but a set of states to apply the same conditions or transitions, which we will discuss further. Then there is something called as linked, which means you can have another state in the tree and you can link to it, in which you can provide another state tree. Just like in the behavior tree, we had this travel behavior which represents the actual travel behavior, and now you can add variations of traveling. For example, we have an escort, we have a follow, and then you isolate these logics in separate trees. So just like this, state tree also provides you to maintain the modularity. Again, we will go into the implementation, and I don't want you to by heart everything. And then we are left with subtree. So the subtree and the linked, these two types work together. So let's say in the root I create a state, let's say state 1. Okay, and if I bring this out on the top, and take the root on the top. Now you can see there are two independent states. Now if you want to transition to another independent state, then you first have to make this state your subtree, and then you can link this state to this subtree. Okay, again we will see how we can use this, but these are the types that AI state tree comes with. Awesome. So you understand the nature of state. Now there is a selection behavior. So you can decide how your traversal would happen. If you go into your behavior tree approach, it will traverse all the nodes in the left side to get where you want at that moment. So for example, if you go in the selector, it will first execute this node, then it will go here. It will check if any companion is left behind or not. And if it is not, then you will continue. But if the companion is left behind, then you will go into the next one, then you will play the animation. Let's say the companion didn't came, it will again go to root, it will again traverse here. There is no point of going here, but still it will go, because this is how the behavior tree traversal works. So this is a big limitation. If I want to get here, I have to traverse all the states that is in my left side of this state to get here. So this is the first limitation, or the overhead, or the extra burden on the engine. So this is why state tree became popular, because it gives you control over how the transitions will happen. Great. Again, don't try to by heart it, just understand what these sections will give you so that you can create the patterns. Again, every state can have multiple states in it. You can create parameters, and let's say if you create a parameter in the root state, all the child states will be able to access those values. Okay, just like a parent class, you created a variable and everyone is able to access, be it your function, be it your event, everyone is able to access. That is exactly what parameters mean here as well. Now there is a second thing called as conditions. Now remember, if you want to enter in a state, then you have to check. These acts like your decorators. So if these conditions successfully passed, then the state will start executing. And when the state comes into execution, it will execute all the tasks that you will provide. So for example, if you want to move towards the destination, you will execute the move to. Again, not going into it, but idea is state becomes active if the state tree pass all the conditions that you provide in the conditions section. Now the most important things about task. All the tasks that you list in this section for any state, they are all going to be started parallel. And if one of them succeeds, the transition section will be notified and you have to make a call. Okay. So just like in the behavior tree, we used to have finish execute that represents the task is successful or failed. Task also have the same thing. There is a list of tasks that you can define. All of them will run in parallel. And if one of them succeeds or fails, the transitions will become active. And based on the conditions or the rules you have defined, the transition will happen and you will go to the next state, or the tree will succeed, or whatever you define here. And whatever was running will be stopped in that state's tasks list. That's all about the state tree. Okay, so if I summarize, schema is the information or the structure that you tell to the state tree about the actor who is going to use it. In the context, you provide those values, and in the parameters, you give some additional information that is required by the state tree. Then there are evaluators which runs constantly. There are only two things you should do. First is constructing the conditions that can be used by the states. Second is fetching the data from the context and parameters. Nothing else. You can execute their functions, you can call their events, everything, but you should not access anything beyond these parameters and context. Then there are global tasks. These boys can run anything. They can update anything. They can be one time. They can run continuously till your state tree succeeds or fails, or they can end it. It's completely your call. So the only thing that you need to know about the global task is that they run before the state tree becomes active. That means the state tree comes into the action. Before that, the global task will get executed. Now it's up to you whether you want to do one time thing or you want to keep them running. Then each state has a name and tag to identify. There is a color, of course. Then there is a type what exactly the state represents. Is it a group? Is it a link to another state tree? Is it a isolated independent state that can be linked through? Then there is a parameters, which is like local variables of the functions. So these are local variables of your state. These are your global variables. These are your local variables. Once the states become inactive, the parameters will be gone, the data will be gone. Then there are conditions which will decide whether you can enter into the state or not, which are basically your decorators. Then there is a weight, which I'm not going to touch right now because this requires a little more practical experience with the state 3, and I don't think I can give that right now. So for that we need a more complex and modular system to understand how weights can help you. So I'm going to park it. Then there is something called as tasks. So once the state pass all the conditions that you have defined for it, the tasks will become active. They will start executing all of them in parallel, and as soon as one of them succeeds or fails, the transitions will become active. And it's like your compiler which you have created, that based on these rules you will make a transition. And once the transition happens, all the tasks will stop and all the data that is associated with this state will be gone. And now based on this raw knowledge, we will start building the state tree. So we are in our level map now, okay? And we have a base class in blueprints under the AI folder, that is the AI default class. This is the base class of all the AI characters that will be in our game. So we can use this, and then there is again a base AI controller class from which you can inherit more controllers for specific characters, but these are the default classes. So all the state trees we are going to create will focus on these base classes so that all children's are compatible, or basically all the characters are compatible. So I have created a folder inside the AI state trees. I'll open this up and I have to go in edit plugins. I have to search for state tree and I have to enable this gameplay state tree. So enable it, restart your editor, and once you do that, you can right click and search for state tree, and it will give you option to create the state tree. Now we would like to go for artificial intelligence because this is something we want AI to control. So we will select this, and now we have to select the AI component, and then I'll name it state tree st underscore escort. So I'll open this up. I'll go in the asset details. There is a root state by default, and it asks AI controller and the context actor. So like I said in the theoretical explanation, you have to provide the actor and the AI controller that is being possessed by it. So our AI controller is the AIC default, and the context actor class is the PPAI default. Okay, this particular state tree is dedicated for this class. So now you see, based on this schema, the context variables types has been changed. So we will compile, save all, and now we will create our first state, which is moving towards the target destination. So move towards target destination. And now what will happen? The state tree will come into the execution. It will go for the root state first. It will check what type of state it is, and then it's a normal state. It will go for a selection behavior. That means all the children's will have a default transition to root. I'll tell you. Then there are conditions. Since there are no conditions, it will successfully enter and it will start executing the task. Since there are no tasks and nor you have provided any transitions, it will go for the selection behavior and it will start executing its child states in the sequential order. So first it will go here. Now again, there are no conditions, no tasks, no transitions. So this will say completed, and it will redirect to root, and root say this child is done. I'll go to the next child state. So for example, state 2. Now once this completes, then it will again transition to root, and the root will say that all the children's are successfully executed. That means state 3 is done. But we do not want that, so we'll remove it. Now move towards the target destination. So there is an inbuilt task that is provided by Unreal Engine, that is your AI move to, which is named move to in this one, and you have to provide the controller. And that's the reason why we selected the AI, so that it gives you this AI controller option in the schema and you can provide the value and now you can bind to it. So that is the second biggest limitation of behavior tree which is being resolved, that is through data binding. Data binding is similar to pointers. First thing, in behavior tree you used to create the blackboard keys and you used to duplicate the data and save it again. Instead, data binding gives you the direct access to the memory location where your data is stored. Now you will be wondering, or at least the people who have done some programming in C++ especially, there are something called as pointers. Now you will say pointers also give you the reference, right? You can pass the reference. Even right now, if I create a parameter and I say, let's say actor, and if I select this, you see it says object reference. And I told you in how programming works that when it comes to object structures, we always share the references, not the entire data, because it can be huge. So we share the references. Now the question might arise that pointers can do the same job. Why do we need the data binding? So pointers indeed gives you the direct access to the memory location where the data is stored, just like this one. But the problem is if the data is invalid, for example, if I select this one, it says none. So if the data is invalid or the memory location doesn't exist or the cache went bad or the data does not exist anymore, the garbage collector took it out or the actor is destroyed, in all those situations, there can be more of course, the data or the memory location might turn invalid and we are not performing any sort of checks here. We are just referencing to it. Doesn't matter if it exists or not, if the data is corrupted or not, we don't care. We are directly referencing. So that is little dangerous approach. So instead we use data binding, which is doing the same thing underneath, but it has certain checks and balances that ensures that whatever data or memory location you are trying to bind to exist in the memory and it is safe and sound. It is not yet corrupted, it is not yet deleted or undefined or any of that sort. It exists. So that is the feature of the state tree, that it gives you the data binding which takes care of everything. I don't know about which version you are using, but sometimes if you try to bind to a variable or a parameter, if they are undefined or if they are not updated, they are just declared, then the editor might crash. Now I'm not able to reproduce, maybe the developers have fixed this, but what I want you to tell you is that data binding is the safest way to bind to a memory location so that you don't have to duplicate the data. You know where the data is, you don't have to duplicate it. Okay, so it's like storing the location or the address. So you can see it gives you the global parameter access. So we'll select it. Now it has binded to this variable automatically. Now if you change this value, wherever it is binded will change as well. So I'll compile and save all. Now what is happening when you bind to this value is here, this address is here. Okay, now if you change this value, all the functions, tasks, evaluators know that my data is kept at this address, and if this value changes, automatically the value will change here as well because you are accessing at this location. Now whatever you do here will be reflected here. So I know the AI controller. Now I need to get the destination, which means I have to fetch my Escort data. Now there are two ways. I told you while explaining the theory, evaluators and global task. Evaluators runs constantly, global task once. Global task run once. Now if I create a global task, you can see there are some default tasks. Now global task is also a type of task, but the only difference is this global task runs before the state tree comes into the execution, and doesn't matter on what state you are, they will provide you the data. But there is a condition. What? I will create a task and I will call this STT underscore escort data. Don't do it, just have a look. It provides you the enter state and the exit state. We will go for enter state. This will be fired once the state tree will come to this. So I'll add it. Okay. So once the state tree comes to this point, it will fire this event and I will fetch the data. So to get the data, I need to know my character, which is stored here. So I need to bind to it. So how do we do that? In the variables, you can create character, and I'll change this to AI default, BP AI default, and I will compile it. And now I can access the get component by class, and I can get my travel behavior component, and I can access the escort data. And now what I'll do, I'll save it in a variable again. I'll call it escort data and I will plug it here. Okay, this is the fetching. Now I need to get this value. So how do I get? Because in the escort, there is no such thing visible. So this data is present inside the context category. So if you provide the category correctly here, then it will be available and it will automatically give you the hint. The IntelliSense that is working behind the engine will give you the hint that it is connected to the context actor and you can bind to it. But let's say due to beginner issue or you do not know much about categorization and you leave it with default, you will see it will not show up. So in that case, you have to manually make it instance editable and that will allow you to access, and you will see it is giving you a default value of none because IntelliSense is not able to detect where this variable is. So if you provide the correct category, it will give you the suggestion. So you can still do this way. But since we know what is the category, I will stick to that and I'll create exactly the same name, context, compile, and I will shut this eye and you can see I can bind it. That is the one solution. Now I have to expose this data so that state tree can use it. So what you will do, the escort data, you will put it in an output category. Okay. So there are three primary categories that developers had created. One is your context that represents the contextual data that is needed. Then second is your parameters, which are inputs, just like function as arguments. Inputs basically means the requirement of the task so that it can execute successfully, and the output, which is the result of that entire task, which can be reused by other people or the entities. So I'll compile, and since I've given it a correct category, it will be available for you. You don't have to expose it from here. Now here's a catch. Now I want to use this data because there is a target destination available in this. I'll go here in the move towards destination. You see you have a task and there is a data available, escort data. And since this destination is of type vector, it automatically shows you all the variables that you are outsourcing of that type. So we can select the target destination. Now the question arises, is this going to work or not? Because once my data is fetched, this is done, the task should end. Will it end? No. Because to end the task, you have to call finish task. If you do this, then this task will successfully complete and it will be moved out of the memory. But there is a drawback. If you mark the task as completed, the data you are outsourcing will be gone as well. For example, companion went out of the range. So you are playing that state and then you come back to this state. Let's say we have a call companion. Okay. Let's say a companion went out of the range. So it will go to this state and then it will play the animation. Once it is in range, it will go back to this state. And now this state again will try to access this data, but it is gone because global task run before the state tree. And since you completed it in the code, it will clear out and the data will be gone. And if I don't do this, the problem is this task will keep running, which means the data that you are outsourcing will be active, the memory location will be valid, and everyone will be able to access the data safe and sound, no problem. But the problem is you are consuming resources because this global task is not doing anything. What it was supposed to do was just to fetch the data. You have fetched the data, now your work is over, and now you're just running so that you can outsource it. No, that's not fair. For these cases, you use evaluators because evaluators don't stop until your state tree completes. So that's the reason we should always stick to evaluators in such cases where you just want to get the data before the tree starts. Okay, so we are not going to do it here. Instead, I'm going to delete this task and actually let's create evaluator first. You cannot create evaluator from here. So you have to go in the blueprint class, search for evaluator, and under the state tree, you will find it. So select it, STE, state tree evaluator underscore track escort. Now we are going to just copy this entire thing and paste here. Now the evaluator gives you three options. Tree starts, because this runs before the tree starts, and we have the tree start, then we have tree stops, And then we have a tick, which runs constantly, just like event begin play and event tick. So I'll say tree start because this is just a one-time thing I have to do. So I'll go here. I need this character, so I'll create this variable and I will give it a category of context. And this is our escort data. So I'll create a variable as well and I'll give it a type of output. Like I told you in the theory that you should use Evaluator to construct conditions and fetch the data from the context and the parameters, and you are just accessing the context actor and you are fetching a data from it and you are outsourcing it. And you can see once the task is deleted, it is showing the error. So we will reset it and we'll get it from the Evaluator. Now Evaluator will not stop until the tree stops. So this way your Evaluator is still running where you can do more things and the data is also available at the same time. You do not have to run a global task for this one. Great. So we compile save all. Does that mean all the long running jobs should be done in the Evaluator? No, absolutely not. That's where I will repeat my line. If the data that you are trying to fetch is part of this context and parameters, yes, you can rely on it. But if you are doing more than just the fetching, then you should move to the global task, because this clearly says track escort, which means it will keep track of companions. It will need the data. So it has fetched the data. That's it, period. Track escort means track the companions, nothing else. If there is anything else required that you want to constantly get from the world, then you should create the global task or another evaluator for that. Follow the solid principles. You will find the programming very, very easy and you will develop scalable solutions. Great. So this is how you fetch the data. This is how you bind it, and you know the three categories. Now I will collapse this, and if I successfully reach to my destination, I would like to fire a transition, and I say, if I successfully completed this task or any of the tasks here, then consider the tree is succeeded. But if not, then just go to root. This is the default behavior. So if it goes back to root, then the root will move to the second children. Now, is this a valid thing to do? I would say no, because in this case, we know that at this moment, the escort can only stop if the companion goes out of the range. So in such case, you can hard code your own transition, which says on state failed, I would like to transition to call companion. So now it's not going to go back to root. Instead, it will go to the desired state that you have selected. So I'll delete this for now and I'll just say if you successfully reach, then I'll say tree successful. Now, how do we run it? I'll save all. And as you know, we have placed this mission here. If you come into touch, the launch escort will be fired. So I'll go to AI default, and you can see in the interfaces we have implemented launch escort. It will fire on travel mode changed, and we are running the behavior tree. So now you can see first you have to run the behavior tree, then you have to set the object, then you have to set the travel mode. All that things are gone. So what I can do, I can delete all this since we are not going to use behavior tree in this particular case. I'll remove all this and I'll just go to travel mode, switch on enum travel mode, and I'll say if it is an escort, then gets the AI controller, get reference to the self, and I have to cast to AI C default. So what I'll do, I'll go to my controller, which is the generalized class, and I'll add a state tree AI. And here I will deselect the start logic automatically because we want to begin the escort when you come into the contact. Till then you will stay in the static situation. So we'll mark it false so that it does not start automatically, and the state tree is escort. Again, we are going to consider a general tree for that specific character, but for this episode, I'm going to consider the escort tree directly. So we'll go back to AI default, and now we can say start logic of the state tree component. So I'll compile, save all, and if I play and I touch the mission, you can see that guy is already going towards the escort position. And also note that you can run state tree from the behavior tree and vice versa. So that's it for this episode. I hope you enjoyed it. I hope it gave you some basic understanding of state tree. We will dive more deeper into each section and we will understand how the transitions and other things happen in action, how we can use those different types of states. We'll cover this in the coming episodes. So like the video, share it with your friends, subscribe to the channel, and if you have any suggestion, feedback or hurdle, you can pin them in the YouTube comment section. And if you haven't joined the Discord community, the link is in the description. Make sure you join it to connect with the other developers and to collect the assets that are used in this series. Apart from this, if you like my work and you want to support me on Patreon, that link is also in the description. But please have a word with me on Discord before buying the membership. Till then, take care. I'll see you in the next episode. Bye.